Your book talks very briefly about superstring theory, and I'm going to talk briefly about it as well. So, superstring theory is probably the most famous attempt at a theory of everything. And again, a theory of everything is a theory that combines the four forces in nature. So you have the nuclear strong force, the nuclear weak force, the electromagnetic force, and gravity. So to understand how the very early universe behaved, we need to understand and we need to have a theory of everything. So this superstring theory postulates that the fundamental particles in the universe are actually one-dimensional vibrating strings of energy. And those strings, each independent quantum number, is thought of as a separate dimension. So there are multiple dimensions in superstring theory. Unlike the three dimensions we're familiar with, up, down, up, forward, backward, left, left and right, and time being the fourth dimension, there are postulates up to 11 or even 13 dimensions in certain superstring theories. Those other dimensions are usually so tiny, they're smaller than the particles that they actually represent, 10 to the minus 35 meters or so. So incredibly difficult to test this theory currently. It is in its infancy. There's some exciting advances where superstring theory has done as good a job as some currently existing theories in predicting the existence of certain particles or why symmetry breaks and things like that. But it has not yet proven to be better than current theories, and in some areas it's actually lacking compared to current theories. So in science, the only reason you pick one theory over another, ideally, is there's more evidence to support that theory. Right now, superstring theory has not yet made any predictions that are testable with at least current technology. Maybe sometime in the future, we will have particle accelerators big enough to test some of the predictions in this superstring theory. It was huge in the 90s. When it first was proposed in the 80s and 90s, a huge amount of funding went into it. A lot of physics labs around the world, physics universities around the world. The departments hired superstring theorists, so the famous Harvard, Yale, Stanford, MIT. But not much progress has been made, at least to my knowledge, over the last decade. I'm sure they're still making slight advances, but not by the leaps and bounds that they did early on. But again, it's still in its infancy. And remember that in the last video we talked about the discovery of gravity waves winning the Nobel Prize in the year 2015. That's 100 years after Einstein's general theory of relativity first predicted their existence. So it can take a while to test these theories. And hopefully superstring theory will pan out, but if not, we will have to keep on working to find some theory of everything if we want to understand the universe at a very fundamental level.